Hello everyone and welcome to my channel. In this tutorial, we're going to continue the implementation of the FastAPI application where we left it in the previous video. If you remember, in the previous video, we added JWT authorization to our API, and in this tutorial, we're going to add database models so that we can link our database records with the specific users and validate access to our records based on the user identity. Before we get started, I would like to ask you to subscribe to my channel. It's a small action, but it goes a long way to supporting me to continue making this kind of content. Now we've got a lot to do, so let's get started. So I'm here in the terminal, and what I've done first of all is I've copied the contents of the previous tutorial into a new folder. The new folder is FastAPI SQLAlchemy tutorial, and the contents of the folder are the same as what we had at the end of the previous tutorial. So we've got the implementation of the FastAPI application, including the server file, the API file, and the authorization module. We've got the API documentation as well. We've got the private keys that we need to use to sign tokens and to validate them. And we've got the JWT generator as well. So the first thing we want to do is to install the dependencies. First of all, let's create the virtual environment with the version of Python that we want to use in this exercise. In this case, I'm using Python 3.5. So let's go ahead and create that environment. Alright, the environment is ready. Now let's install the dependencies. Alright, the dependencies are already installed. Now let's install the new dependencies that we need for this tutorial, which are SQLAlchemy and Alembic. Alright, the dependencies are installed. Now we can start working on the application. Before we do that, let's give it a little bit more structure. We're going to keep on adding more files to the application, and the application is already looking a little bit unstructured with so many files spread in the root directory of this repository. So let's create a few folders and organize our files a little bit more so that it starts looking more like an actual application. So we are going to create an API folder which is going to contain the implementation of the API. And inside of this folder, we are going to move all the files which are relevant to the implementation of the API. So that is the API module, the authorization module, the server module, and the pedantic schemas as well. So that goes into the API folder. Right. The next thing we are going to do is to create a data access directory, which is going to encapsulate all the logic which is necessary to interact with the database. In this exercise, it's only going to contain one file called models, which is going to contain the SQLAlchemy models, but in more complex applications, it can contain additional models files, additional logic necessary to interact with the databases, and some other files. So let's go ahead and create that. And inside of this directory, we're going to create a models file. Now, inside of this file, we're going to implement the SQLAlchemy models. Before we do that, let's initialize Alembic so that we can manage our database migrations from code. So what we need to do is run Alembic init migrations. Oops, we need to activate the virtual environment first, so let's do that. And now we can initialize Alembic. Alright, so this command has created a folder called migrations, and inside of this folder we have a number of files like env.py, which contains configuration for Alembic, and also versions, which is going to contain the list of migrations that we are going to apply into the database. It also creates one more file called alembic.ini, which also contains configuration for Alembic. Let's go ahead and edit this file to add the address of our database for Alembic. So we open alembic.ini, we search for a line that contains the SQLAlchemy.url parameter, and we are going to edit the URL to point to a database. Now, to keep this tutorial simple, we're going to use an SQLite database so that we don't have to start up an additional database server and interact with it. So that's going to be SQLite models.db. Alright, the next thing we're going to do is to edit the env.py file. So let's open the file. And here we need to do a couple of things. So first of all, we need to import the base model of our classes. We don't have that base model yet, but we're going to have it very soon. And we're going to say from data access import base. And then we need to point to the metadata of this base class, which is going to be base.metadata. We delete this line because we don't need it. And that is everything we need to do. Alembic is already configured to run migrations. So let's go ahead and implement our SQLAlchemy models. So SQLAlchemy models are classes that represent our database tables, and they map class properties to database columns. There are two ways of declaring database tables using Alembic, and the method we're going to use here is using declarative models. To be able to implement our database tables declaratively, we need to get an instance of the base declarative class from Alembic, and we do that by using Alembic's declarative base function. It looks like this. Base equals declarative base. We import this function from SQLAlchemy, and now we're ready to start building our models. We're going to build two models here, a user model and a model for the tasks that the user creates through the API. First of all, we're going to create the user model. So that is class user, inheriting from the base declarative class, and this is going to go in a table called users. And then we define the columns of this table as properties of the class. So we're going to have an ID for the user, which is going to be a string, primary key, true, and we're going to have a default function for generating the ID. The reason we put it as a string is because we want the ID to be a UUID, and SQLite doesn't natively support UUID as a type. So we are going to create the value using a function, using a custom function, and the type is just simply going to be a string. So the default is going to be generate UUID, which we are going to implement in a second. Let us import these dependencies. And generate UUID is going to look like this. So we simply return a string representation of a UUID value. The next thing we want to add here is a created field so that we know when the user was added to the database. And that is going to be a datetime property. And it's going to be non-nullable. Next, we are going to add an email property for the user, which is going to be a non-nullable string as well. Now, a user owns a collection of tasks. The main point of this API is to allow users to create tasks to manage their schedule. So we're going to add a relationship to this table, which is going to point to the collection of tasks which is owned by the user. That's going to look like this. Now the task model doesn't exist yet. We're going to create it right now. So that is going to be class task. The name of the table is going to be task. And it's going to have all the properties that the user sends to the server to represent a task, together with a few additional properties that we need to have a full representation of the task. The first of them is an ID. Every task has an ID. And that also is going to be a string because it's going to be a UUID. If you look at the Pydantic model, every task has an ID which has a UUID format. And this is what we want to have in the database. Every task also has a property called created, which is a date time, which represents when the task was created. It has a priority, it has a status, and it has the name of the task itself. So let's go ahead and add these properties as columns into the task model. So the ID is going to be a primary key, and to generate it, we're going to use our custom generate UUID function. The created field is going to be a date time. It's non-nullable. We're going to have also a field telling us when the task was updated so that we can keep track of that. And that's also a date time field. And non-nullable as well. When the task is created, the value of updated is the same as created. Then we have priority, which is a string and also non-nullable. Then we have status, which is also a non-nullable string. Then we have task, which is also a non-nullable string. And finally, we have a pointer to the user who owns the task, and that is going to be a foreign key relationship with the user table. It looks like this. Alright, so every task is linked to a user through the user ID foreign key, and with this information, SQLAlchemy is capable of building the list of tasks bound to the user through this special relationship property that we have here. Now we are going to enhance these models with one method, which is going to be very helpful for us to inspect the properties of each record. And this is going to be a method that returns a dictionary representation of the record. For the user, it looks like this. Alright, and for the task model, we're going to have a dictionary method that returns a representation of the task as required for the API. So we're not going to include all the properties of the task. We are only going to include those which are needed to send a full representation of the task to the user through the API. So that is going to contain the following properties: ID, created, priority, status, and the name of the task. Alright, our models are ready, so let's go ahead and create a migration that we can apply to the database to create these tables. To run the migration, we run Alembic like this. So we tell Alembic to generate a revision, which is the concept that Alembic uses for migrations. And we say that we want to auto-generate the migration by inspecting the models that we have defined using Alembic. And we give a name to the migration so that we understand why it was created. Let's go ahead and run this command. We've got an import error here. It tells us that it cannot find the base class within data access. And that's true. There is a file within data access. We should be importing from within the file, not directly from the folder. Alright, so the migration has been created. We can look into this file. What you're going to find is a collection of SQLAlchemy statements that create the table together with the columns, the primary key constraints, and things like that. And it contains two commands, one which is upgrade, which applies the migration to the database, and one which is downgrade, which rolls back the changes that we created through this migration. Now that we have the migration file, we can apply it to the database. And we'll do it like this: Alembic upgrade heads. Alright, the migration has been applied. Now we have one new file within our directory, which is models.db. And this file represents our SQLite database. We can already start saving our records to the database. The first thing we're going to do is to create two user records so that we can test our API authorization with two different users. To create the users, we're going to use a Python shell. And to create them, we simply need to get the database connection, create a session, and create the users within the session. Let's go ahead and do that. So we say from SQLAlchemy import create engine, and from SQLAlchemy ORM import session maker. Now we also say from data access models import user. We are also going to need the datetime library to add the timestamp of when the record was created. So let's go ahead and import that. And now, first of all, let's create a list of users with the right properties, and then we save them to the database. So we say users equals So we simply need to give the properties created and email to the user. And we're just going to add some random values for the email, and the created property is going to be set in UTC so that it is the same time reference everywhere. Alright, so that's the list of users. And now to interact with the database, we have to create a session maker object, which is going to allow us to create sessions to perform our transactions within the scope of the session. To create the session maker object, we have to use the session maker function from SQLAlchemy, and this function requires a parameter, which is a connection object to the database. And we create this connection object using the create engine function from SQLAlchemy. It looks like this. Right. Now, this session maker is a factory method that returns session object, and it works like a context manager. A context manager in Python is an execution context which encapsulates the operations that we are executing and allows us to perform certain actions before we enter the execution context, and ensures that we execute certain actions once we exit the execution context. So what the session maker is doing is it starts the session with the database before we perform the database transaction, and it closes the transaction once we finish the database transaction. We use it like this. Alright, our users have been saved to the database. Now we can query the database to get the user records, and especially get the ID of every user, which we're going to need to generate the JWT tokens for each user. So we say remember that we added a dictionary method to the user model so that we can get a better representation of the object. This is how we leverage this method. We get a nice representation of this data with all the properties that belong to the user. We have the ID, the created timestamp, we have the email, and we have the list of tasks, which is empty because we don't have any tasks associated with the users just yet. Now the important bit here is the IDs. We're going to use these IDs to create the JWT tokens. So let's go ahead and do that. To create the tokens, we are going to use the JWT generator that we had from the previous tutorial. And what we're going to do here is, instead of creating tokens with random IDs, we're going to specify the ID that we want to use. So let's go ahead and create first a token with this ID. And this is the token for user number 1. Let's save it somewhere so that we can reference it later. And now let's create a token for the user number 2. So we need to fetch the ID from here, paste it here, generate the token again. And this is the token for the second user. So with these two tokens, we are going to be able to check whether the API is validating access to resources based on the user identity. All right, now that we have our database models and our user records, the next thing we need to do is to create an instance of the session maker object. And we're going to do it in the server module because it's a common place where we can put things that have to be imported by the API layer. So we go within the API in the server. Here we are going to create this instance of the session factory. So we say session maker equals session maker, and we bind it to the database connection object. We import these dependencies. And we also need to change the import statements of the application because we have restructured the application. The import statements that we had from before don't work anymore. So let's go ahead and fix them as well. So we say from API auth import this. In the API module, we import the schemas from the API folder and the server as well. All right, now we can go ahead and complete the implementation of the API by making use of the database models to make sure we link every task with a specific user. We're going to start by changing the post method so that we can immediately create a few tasks bound to a specific user. And we do it like this. So the first thing we're going to do is to create a new database session to perform this transaction. And we do it using the session maker factory that we instantiated in the server module. Then to save a task, we are going to create, first of all, an instance of the task object, like this. So we import the task model and we add the request object to the function signature so that we can use it in the body of our function. Now remember, the user ID is available in the state object of the request, and we access it this way: request.state.userid. Now we have the instance of the task record. Now we need to add this record to the database session and then commit. And now that the record is committed, we can obtain the full representation of the record from the database. And we do it like this. Using the dictionary method that we created earlier to obtain a nice representation of the record. One important thing here is you need to make sure you access the object information within the scope of the session. Otherwise, once you exit the context manager, the session is not available anymore. So there is some data that was added by the database and it won't be accessible once you exit the context manager because the session has closed. So you need to make sure you call this method within the scope of the context manager. Now the session has already been saved to the database. We don't need to append it to the task anymore. So we just simply return it to the user. All right, so this is already something we can start testing. So let's go ahead and start the server. Talking about the import statements, we have to make sure we load the OpenAPI specification file from the right place now. So let's go ahead and do that. So this is one folder app because we created the new folders. All right, so the server is running now. Now let's grab the token of one of the users from user1 and let's use this to sign the request. So we authorize it, we close, and we use the post method to create a few tasks. A few more import statement problems. So the public keys are not in the same folder as the API, so we need to make sure we load those keys from the right place. So let's go ahead and change the auth module, and this is one folder up again as well. The server is automatically reloaded because we are running it with the reload flag, which makes sure the server reloads every time we change the files. And we can just simply execute this again. Now the response here is not found. And it looks like the API is not actually loading the functions. And that makes sense because we forgot to change one more thing about the import statements. So if we go to the server module, at the end of the file, we are loading the API implementation from the API file. Now, this has to change because the file is now within the API folder. So what we need to do is import API. This is now going to load the functions and register them with the FastAPI application so that they become endpoints of the application. So we can now run this again, and the task is created. So let's go ahead and create a bunch of them. All right, we have a bunch of tasks now created. So now let's go ahead and implement the getToDo endpoint to retrieve those tasks from the API. So what we are going to do here is create another database session. And within the scope of the session, we're going to query the tasks that belong to the user. Now, if you remember in the model, we have a tasks property which represents the tasks that are bound to the user. So we can leverage this relationship to simplify the query with the database and return the tasks to the user. So it looks like this. So what's happening here? We are querying the database, the user table, and we are filtering the records by the user ID. We already got the user ID from the request state object in the previous tutorial, so we are just making use of it here. Now, to query the database and filter by specific columns, there are two ways of doing it in SQLAlchemy. You can use the filter method, or you can use filter by. If you use filter by, it would look like this. So with filter by, you can run your query using keyword arguments. Using filter, you have to use the SQLAlchemy model and use the specific properties of the model to run your filter statements. Which method you prefer is up to you. The advantage of this method is that you have direct access to those properties and your development editor is aware of that. So if at some point you change the name of one of these properties, your development editor will be able to change these names here because it knows the connections between the properties and the models. Using filter by and therefore query arguments, it's up to you to make sure that your queries are up to date using the correct properties in the function call. Now, we got the list of tasks that belongs to the user by fetching them from the relationship, and we just need to inject them here in the payload and send them back to the user. So server is reloaded because we changed the file. Now let's run the getToDo endpoint and see what happens. It's complaining that the task is not a dictionary, and that's because we forgot to invoke the dictionary method here. So let's do that and let's run the method again. All right, and we got the list of tasks. This is looking good. The next thing we're going to do is to implement the rest of the endpoints in the API, the get, put, and delete methods of the resource endpoint of the task. So let's go ahead and do that. So what we need to do here is, first of all, like always, create a new session to perform our transaction with the database. And we need to query the database for the ID of the task and the ID of the user who's sending the request. So we're going to add the request here to the function signature so that we can access the user ID from the request object. And we say task equals session query. We're going to query the task table this time. And we say filter task ID equals task ID. And task user ID equals request state user ID. So we run the query and we fetch the record invoking the first method on the query. There are two methods that you can invoke here. One of them is first, the other one is one. The difference is one is going to raise an error if the query raises an empty, if the query doesn't return any results, while first is going to return none if it doesn't find any record with these query parameters. Which is the right method to use depends on the requirements of your application and whether it makes more sense to raise an exception or to return none. That depends on the requirements of your application. In this case, we're happy handling a non-return value, so we're happy to use first. And what we say is if task is none, we raise an exception. So we are going to send an error response to the user. And here we have two options. We can send a 401 response, meaning that the user is unauthorized to access the requested resource because they don't own it. Or we can send a 404 response, meaning that the item that was requested by the user wasn't found in the server. Which is the right response depends a little bit on the requirements of your application. But bear one thing in mind. If you respond with a 401 response, you're actually revealing details about your server. If the user is requesting an item that they don't own and you tell them that they are not authorized to access that resource, you're telling them that the resource exists in your server. And if they are a hacker, they may want to play around with the tokens and the security of your server to see if they can get access to that record. If you tell them that the resource wasn't found, well, that's all they know. They don't know if there is actually an entity in your server with that ID, so you're not revealing this kind of information. This is what we call security by obfuscation. We're not revealing certain details about the server, so we're not giving users ground to play around with the server and try to get access to what they don't own. Again, which is the right response depends a little bit on the semantics and the specific requirements of your server, but for security purposes in this case, we are going to return a 404 response, so if the user doesn't own the resource, they don't need to know that the resource exists. So that is going to be an HTTP exception with a 404 response, and we just need to copy the details from here. And that's all it takes. And then if the task exists, we are simply going to return the dictionary representation of the task to the user. Let's go ahead and test this method to make sure it works. So we grab one of the IDs here and we go to the get to do ID endpoint and we test it. We paste the ID here, we execute, and it is complaining that the task model doesn't have a user property. Now let's go ahead and double check that. So in the task model, actually what we have is user ID. I forgot that. So let's go ahead and fix the query so that we are referencing the right property. So we say user ID. So let's go ahead and fix that and run the query again. And we're getting another error. And the error is a little bit difficult to understand, but if we read carefully, what it's saying is that there is a problem binding the first parameter of the query to the filter value. The first parameter refers to the task ID. And if you look at the representation here, what we're sending is a UUID object instead of the string. If you remember, the ID in the model is represented as a string, so what we need to do here is get the string representation of this UUID, and we do it like this. All right, so let's run this again. And we got the task. So it's now working. Now we have to implement the rest of the API endpoints, put and delete. And we follow the same approach. We get the database session. And we run a query just like we did here. And if the task isn't found, we are going to return a 404 response. Now, if the task is found, we're going to update the whole representation of the task with the payload that's been sent by the user. So we say task status equals payload status value, task priority is payload priority value, task updated is now the current time, and task is the task from the payload. Now this is actually nested within the scope of the session, and what we do now is session at task, we commit, we get the dictionary representation of the task, and we return. We also need to add the request object here in the function signature. And now let's implement the final method. We can copy from here. We open the session. We add the request parameter here as well. And we open the session. We query the task based on the task ID and the user ID. If the task isn't found, we return the 404 response. And if the task is found, what we do is session delete task and then commit. All right, let's go ahead and test these methods. So using the same ID, we're going to update the properties of this task. And we're gonna say that the task is do FastAPI with SQLAlchemy tutorial. Oh, that's the status, so it should be here. The status is progress, and the priority is high. Right, so let's execute this. And we've got the updated representation of the task. Now let's run the get to do from the resource endpoint again to make sure this also returns the right representation, and it does. Now what we can do is delete it from the database and make sure the task doesn't exist anymore. So we run this, and 204 empty response. That's exactly what we expected. Let's go back to the get endpoint and make sure the task doesn't exist now, and it doesn't. Right, so the endpoints are working correctly with the correct user. Now let's change the token to the other user and see what happens if we request resources that don't belong to us. So we go back to this file, we copy this token, we use it to authorize the request with a new token. We run this method and we should get an empty list, and we do. Now let's sign the API again with the previous token. Get the list of tasks, and we're gonna copy this ID. We're gonna save it here. Now we grab the second token again. We log out. We sign in with the second user. Close, and we're gonna see if we get the 404 response when we try to access a task that actually exists on the server. And yes, we do. This is exactly the response that we want from the server. So there you go. You've just learned how to link specific records to users and how to validate access to those resources based on the ownership. So you're now ready to protect access to your resources in your server based on the identity of the user. This is everything I wanted to say. I hope you enjoyed this video and you found it useful. If you did, please like the video, leave a comment, share the video with your network, with your colleagues. And if you would like, leave a comment suggesting new topics that I can cover, any question or topic that you would like me to address in a following video. And if you found this video interesting, you will also like my book, Microservice APIs with Examples in Python. This is a book fully dedicated to explaining how to build microservices and APIs in Python. Check out the description in this video. I will leave a link which you can use to download 2 chapters of the book for free, and also a code which you can use to get a 40% discount from the book. I will also leave the URL to the book in the Manning website so that you can check it out. This is everything I wanted to say, and I hope to see you soon.